What is up, guys? Welcome to JS Racing. My name is Jason. In this video I'm going to show you all the upgrades that I'm going to be implementing for the electronics on the Inertia Dyno project. Now, with all the upgrades, it's going to unlock a lot of new features for us, such as electronically controlled throttle and braking, lap simulations, EGT, humidity, air pressure, all that stuff. So it's gonna make the dyno and also the data collection a lot cooler, a lot better, more information to reference on, and also better data for you to be tweaking the carburetor with. So yeah, but before I get started on telling you guys all about the upgrades, we're gonna have to deal with this first. That's all the parts that came in the mail, but I have not had the chance to unpack yet. So we're gonna have to unpack all that and then put it together, and I'll show you real quick how it looks like, and then I'll solder it together, and then I'll show you guys the final, well, semi-final product. Anyway, so let's get started. Alright, so all of those parts were actually sitting on this desk for at least 1 to 2 months. I just never had the chance to put them together because I was busy working on some other big project. So now I'm going to roughly put it together so that you have a general idea of what everything is doing, and I'm going to explain some of the major components of this build so that you also know that what is this unit going to be capable of. So bear with me for a bit. Alright, so these are basically the major components of the build. We have 2 very powerful servos to control the throttle and the brakes. I have an optical encoder to do the RPM of the flywheel. This is going to be a lot more accurate, and it's going to be impervious to vibration, at least more impervious than the previous build. Now, this is a UBEX. This one is basically a voltage converter for the servos, and this is the exhaust gas temperature that this attaches to the optical converter. But on top of all of these, if you look at the board here, I'm going to zoom in a little bit more. All right, so looking closer at the logic board, these are basically the key elements of the logic board. The rest are just like connectors, resistors, capacitors, all that stuff. I got a couple of fuses there to protect the circuit, but yeah, basically all the key elements are here. This is the buck converter, so it's a 12-volt supply, so it's going to come in and then it's going to convert, step down the voltage to 5 to support the other logic board. So yeah, that's basically how it's going to supply the power, and then the rest is going to be like 12 volts coming out. It's going to feed into this UBEX module as well, so it's going to convert some of that power to the 2 servos. Now, these elements here, that is a BME 280. So that is for humidity, air pressure, all that stuff, temperature, whatever. This is another temperature sensor, but that is more for engine oil temperature or water temperature. That is just an LED module, but that LED module is going to be very crucial because obviously this is going to be covered, so it's going to look like that. And I'm going to drill a hole there for the light to come through, but basically that's going to be a status light, so it's going to be very important for that to show up. So I'm going to have to drill a hole there. That's the actual processing unit. It's going to plug in there. And this is the Lutana AFR sensor module. It comes in like this. It has a CNC case, but I took it out, and then there are a couple of serial ports that come out. So it's perfect because I can just connect this to the logic board and I'll be able to read all the readings from this unit. So I don't need to, create my own AFR sensor. This is already all calibrated, everything's done, and there's a screen. So yeah, this is fantastic. So anyway, so you can read the readings from this LCD screen, but obviously the app can control this unit, can read all the data wirelessly as well. So yeah, that's basically what it's going to look like. Okay, so now that I've shown you roughly how the components are laid out, I'm just gonna have to solder it. That's gonna take me some time, but obviously in the video I'm not gonna show all that. So cut away.
Alright guys, so I finally finished installing all the components into the new dyno, and I'll just show you real quick what it looks like. Alright, so this is the box that I have created for the new data logger, and I only connected 3 peripherals, and that is 2 servos and 1 optical encoder, and then these are the 3 other, 4 actually, 4 other sensors, and I'll go through them one by one because I don't think I actually went through the sensors too much. So for anyone who's seen my videos, you may not recognize the location that I'm at right now because this is actually the new track that we've completely built. So I'll do another video telling you about and showing you the new track, but I'm here because my previous Inertia Dyno was sent here, so I had to come here and modify the existing Inertia Dyno so that I can test all this new stuff. But anyway, so let me just go through all the sensors real quick, and then I'll show you how it works with the app. So this is the Bosch AFR sensor. It's supposedly a very accurate and very good quality sensor, but I don't think we'll be able to test this time because we have to modify the header of the exhaust so that we can actually screw this in. So this we won't be testing this time. Now this is an exhaust gas temperature sensor. I've already soldered the connector. It's a waterproof connector to the box. So yeah, so this is just a exhaust gas temperature sensor. The next one is this is an oil temperature sensor, engine oil temperature sensor. So again, it's using our waterproof connectors. Now this is going to be connected in the the port where you pour the engine oil, and also where you have the dipstick. That's where it's going to. So we're going to have this big adapter nut, and it's going to screw in here, and this goes into the engine oil port on the case cover. So that's where it goes. And then this sensor is an oil pressure sensor. Now this you probably won't be using, but because we have a oil filtration system, and we can adjust the pressure of the pump that pumps the dirty oil into the filter and all that. So we actually want to see how it performs, and probably adjust the pressure of the pump, because if the pressure of the pump is too high, it's actually going to put a lot of strain in the gears as well. So that's why we have an oil pressure sensor. Now in the previous shot I showed you the optical encoder. So this is what it looks like. This is very smooth, and there's a spring-loaded arm that when you install it onto the chassis, or well, the frame of your Inertia Dyno, it will push against the flywheel to make sure that it's going to detect the rotation of the flywheel properly. And there are 600 pulses per revolution, so this thing is very, very accurate. And this is the throttle servo. So I have created a case that holds it. I have modified the connection as well, and yeah, this is supposed to be pulling on the throttle, and then this is a very strong servo that is supposed to be pulling on the brakes. Again, it's using the same casing. Let me just connect to the data logger with the app, and I'll show you real quick how it works. All right, so this is the JSR Dyno app. I don't know if I've shown you this interface before, but this is on an iPad. So the data logger will emit an ad hoc Wi-Fi network. So I just need to connect to that. So look for JSR Dyno. There you go, JSR Dyno. Oh, there you go, JSR Dyno. Sorry. Then you can see it, JSR Dyno. Don't worry about that. There's no internet. Yep. So then you go back to the app, and then you just connect. Connect. There you go. So now it's collecting all the data coming from the data logger. Okay, you can see that it's running at the moment. So let me just show you real quick how these work. So this is the throttle. We can set the position of the throttle like this, and for this, that's the brake. And I'll just show you real quick the brake. And again, it's very responsive, it's very, very quick. So I'm gonna have to install this onto the frame and see the travel distance and adjust the servo position, because in the settings we actually have a calibration, and I actually added an automatic calibration tool where it allows the app to find positions of the servo, testing all the pulses and making sure that the positions are correct, and you can set the positions. But anyway, so again, you can see that I've added all the curves, the curves. So if you play these curves, okay, let's just do the step. I like the step. So let's load it to the machine, and then I can just start the curve, and you can see that this servo will start moving by itself. Yeah, and then it will stop at the step, and then it will start moving again, and it will start moving again. So, I mean, I'm gonna adjust the timing, but that's basically what it's trying to do. So the next thing I'm gonna show you is the optical encoder. So this is where we use to capture the RPM of the dynos. You can see from here that is the RPM. So let's turn this. But anyway, you can see that the RPM is going up. Oh, shit. There are still a couple of software bugs I'm trying to fix, but you can see the roller RPM there. There you go. So I'm spinning the optical encoder, and it's registering the RPM, and also it's going to convert the RPM with the torque, because I'm actually spinning it with my fingers, and it's actually spinning quite quickly. So it might register it as a very, very high horsepower. But anyway, so that's pretty much how it works. Now I'm gonna have to install everything onto the Inertia Dyno and test it, so I'll probably just post another video about that. But yeah, so everything's working. I'm pretty happy with the results, so I'm gonna keep you guys posted to see how accurate this thing is. I mean, there's still a lot of bugs that I need to deal with on the app, so yeah, I'll keep you guys posted. And that's it for this video. If you guys have any questions, just leave them down in the comments, and I'll try to answer them as much as I can. See you guys.